Good afternoon, everyone. Today we're going to talk about waves. First, I'd like to introduce the different methods of classifications of waves. The first method is based on the directions of the waves. If the waves with vibration directions perpendicular to the propagation directions are called transverse waves, and those waves with vibration directions parallel to the propagation waves are called longitudinal waves. And so, can anyone give me some examples of longitudinal waves? Okay.
Earthquake.
Actually, earthquake waves consist of both transverse and longitudinal waves. So it's more complicated. And so the simple, very common longitudinal waves in life is our sound waves. And also if you apply, and also the wave traveling inside a spring is also a longitudinal waves. If you apply an oscillation at one end of a spring, the wave when the wave is traveling inside the spring, the spring will display pattern like this. These are tight coils and these are loose coils. If you take one point on the spring, you'll find it vibration in this direction, in x direction, and also the wave is traveling in this direction. So that's what I mean by these two directions are parallel. So that's why it's a longitudinal wave. Another simple example for a transverse wave is a wave traveling inside a string. If you apply an oscillation at one end of a string, while the wave is propagating in this direction, each point on the string will vibrate in the vertical direction. So they are perpendicular. So that's why it's called a transverse wave. Another method to classify waves are based on whether they need medium to propagate. Those waves who need medium to propagate are called mechanical waves. A typical example of mechanical waves are our sound waves. So that's why we cannot talk while we walk if we are on the moon, because there's no air for the sound wave to travel in. But there are waves that can travel in vacuum. They are electromagnetic waves, and so that's why if we use a wireless device, we can the astronaut on the moon can communicate with people on the Earth. So even if there's no air through the space. After the second topic is the harmonic waves. It's the most simple and basic waveform, as displayed in this picture. There are some concepts you need to know before we go to this third topic. On the harmonic wave, there are these points on the wave. The points with maximum upward displacement are called on the waves are called crests, and the points with the maximum downward displacement are called troughs. The wavelength lambda is the distance between two consecutive crests or two consecutive troughs. This is lambda 2. And the amplitude A is the maximum displacement of a wave. The frequent actually the period T is the time of a complete cycle of oscillation of a wave, and the frequency f is the number of periods within a unit time. So it's actually the reciprocal of the period t. That's the relationship between these two concepts. The third topic I'd like to introduce is one of the most common properties of waves. It's called interference. There are conditions for interference to happen between two waves. These two waves have to be in the similar, or these waves have to have similar or exactly the same frequencies, and they need to propagate in the same direction. The testing rig of interference experiment is actually pretty simple to set up. First, you need an empty room, and you need to put some source in the center of the room. For example, your radio, and the sound wave will propagate along across the space, and you need to have two windows on one wall of the room, so that the sound wave can be divided into two exactly waves, which are near each other, so that they can display the interference pattern. So let's indicate the two windows as 2 points, emitting exactly the same waves. So these curves indicate the points where a crest or a trough appear on the wave. So at these points, where the curves of the two wave sources intersect with each other, these are points where a crest of a wave encounters a trough of the other wave, or two crests encounter each other, or two troughs encounter each other. At points with two troughs or two crests of the two waves encountering each other, the condition will be the summation of the two. The result will be the summation of the two waves. So we say that a constructive interference happened at these points, like this. So you will achieve a two times larger amplitude. And at points where a trough of a wave encounters a crest of a wave, okay, the condition will be canceling of these two waves, and the result will sometimes be the total cancellation of these two waves. So that's what we call a destructive interference at this point. Okay, so that's all for today's topic. See you next class.